Summer homework problem number 47 asks you to simplify this really ugly expression with exponents in it. And there are a few properties of exponents you need to know to be able to do this. The first thing is if you have two exponentials with the same base, in this case x, and they're multiplying, you can add their exponents. So x to the a times x to the b is x to the a plus b. For instance, x to the third times x to the fourth is x to the seventh. The next one you need to know is that if you have two exponentials that are dividing and they have the same base, you can rewrite it as x to the a minus b. So for instance, if you have x to the seventh divided by x squared, that's equal to x to the 7 minus 2, which is 5. The next one you need is that if you have an exponential to a power, the exponent will multiply. It'll be x to the a times b. So for instance, if you have a squared b to the third to the fourth power, this exponent will multiply times each of these exponents, and it'll be a to the eighth times b to the 12th. Notice that it distributes here. The next one you need is that anything to the 0 power is 1, not 0. Every once in a while there'll be a kid who writes that x to the 0 is 0 and they will get everything wrong. Anything to the 0 power is 1. And the last thing is that anything to a negative power is the reciprocal of the original thing. Notice that there are a few things you need to be aware of for this. Let's say you have x squared over y to the negative 1. The reciprocal of this fraction will be 1 over x squared over y. And when you divide by a fraction, that's the same as multiplying times the reciprocal, which is y over x squared. So a shortcut way of thinking of it is that anything in the denominator moves to the numerator, anything in the numerator moves to the denominator. So let's go back to our original problem, and we'll see it's this giant thing to the negative 1. You can do this in a number of different orders. The first thing I'm going to do is notice that since all of this is to the negative 1 power, it's going to be 1 divided by the whole thing. So everything in the numerator will move to the denominator, everything in the denominator will move to the numerator. So this is equal to 2u divided by 2u to the fourth, v to the negative 2, times u to the 0th, v squared. The next thing I'm going to look to do is see what I can simplify. Notice that we have two coefficients, and there's no special rule about coefficients. You can divide them just like normal. When you have a fraction and you have coefficients, you can divide both the numerator and the denominator by the same number. In this case, we'll divide them both by 2, and so they'll just be a 1. These will cancel out. The next thing I'll notice is in the denominator, we have this u to the fourth, u to the fourth times u to the 0th. We can add because they're multiplying. So I'm going to leave the u alone on top for a second. And 4 plus 0 is 4. So u to the fourth. We also have v to the negative 2 times v squared. They're multiplying, so we can add their exponents, and we'll get v to the 0th. The next thing I'll notice is that anything to the 0th power is 1. So this v to the 0 is going to equal 1. The u's, remember that if you're dividing, you can subtract. Usually you subtract from the bigger one. So 4 minus, this has an invisible 1. 4 minus 1 is 3. So we're going to get u to the third in the denominator. If there's nothing left in the numerator, we need to put a 1. U to the third times 1 is 1. And so we get 1 divided by u to the third. This is simplified because it doesn't have any negative exponents. It doesn't have any exponents that can be simplified in any way.